try this again. This is our Unit 13 seminar on the quadratic formula, and I would like you to copy the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. Boys at the back, I do not see you taking notes. Come on, get out paper and be ready to take notes. Put your bags on the floor. So it looks quite complicated, but it really isn't. Once you memorize, you do have to memorize this formula for the Unit 12-13 test. The 12-13 test will cover all the material from Unit 12 as well as Unit 13. So in Unit 12 and Unit 8, we came across scenarios where you were given a quadratic equation that you weren't able to factor. Because up till now, in order to find the roots, so when I say roots, I'm talking about the x-intercepts of a quadratic equation. In order to figure that out, you were using trial and error. That was your one strategy. We used the vertex to complete the square. But for x-intercepts, you were mainly just using the quadratic formula. In this seminar, I am going to teach you a method. It's called the quadratic formula, and you can use this formula to calculate any square root of a quadratic or find the x-intercept of any quadratic function. That being said, sometimes you're not going to find roots. For example, this is a quadratic function, but it's floating in mid-air. So this is a scenario where your d value is less than 0. And when d is equal to 0, we have 1 x-intercept. When d is less than 0, you have 2 x-intercepts. However, I haven't mentioned what d represents. Inside the quadratic formula, you will see b squared minus 4ac. That's sitting inside underneath the radical sign. We call this the discriminant. It's spelled discriminant. Now there is a typo in your unit guide, so I need you to listen very carefully. I believe in your unit guide it defines a discriminant as the square root of b squared minus 4ac. That's a typo. The discriminant is identified as the formula b squared minus 4ac. So when you're doing your unit work, please do not put a square root. This is what the discriminant is, and the value of the discriminant, the reason why it's so important is by identifying or looking at the discriminant, we can figure out right away how many x-intercepts our graph has before we put it in our graphing calculator or sketch the function, okay? So every time on your test and in your unit guide, when you are using the quadratic formula to solve for your roots, first of all, I want you to calculate your discriminant. So this formula is a little bit complicated to use, so I want you to kind of use the discriminant to be aware of how many roots you're looking for before you go through the whole process with the quadratic formula. And there's key little elements where a lot of people have difficulty with when they use the quadratic formula, so I'm going to highlight that when we do our questions today, okay? So let's start with the first example. When d is greater than 0, my situation is I have 2 distinct real roots. That means the quadratic function is going to cross the x-axis in 2 different spots, okay, whenever d is greater than 0. So we are going to do the first example. So let's say you are given the equation y is equal to 2x squared minus 4x minus 3. So this is our equation. I'm going to write my quadratic formula as my first step. Remember, you have to memorize this for your test. Negative b plus minus the square root of b squared minus 4ac all over 2a. Formula looks complicated, but the only thing you need from the quadratic equation, your original equation, in order to plug it into the quadratic formula is your a term, your b term, and your c term. So first thing I'm going to do is I'm going to write down my a term. A is equal to 2, b is equal to -4, and c is equal to -3. I'm going to use this information in my quadratic formula eventually. However, the first thing I want to do is to figure out whether my discriminant is in fact greater than 0, and so I know that I'm looking for 2 distinct real roots, okay? So what we're going to do is calculate my discriminant. D is equal to b squared minus 4ac. b squared minus 4ac. So I know that my b value is -4. So -4 squared minus 4 times my a value times my c value. I want you to pay particular attention. B squared is by itself. That's one value. And then the -4 times 2 times -3 is going to give you a whole different value. These three numbers are being multiplied together. So when we actually perform my calculation, Pamela, what is -4 squared? Equal to 16. Good. And if I multiply -4 times 2, that's going to give me -8, times 3 is going to give me positive 24. So when we combine those two values, 16 plus 24 is going to give me a discriminant value of 40. Okay? So now that I know my d value is greater than 0, so I definitely will have 2 real roots, I can now take my a, b, and c value and I'm going to plug it in to the quadratic formula and plug our values into the quadratic formula. Before we do this, I want you to look at the board for a second. The major mistake I see made on tests is this part of the quadratic formula, the -b. What this means is whatever your b value is, when you plug it into just this first little part, you have to switch the sign. So if we start off with a positive b value, it's going to turn into a negative b value. If we start off with a negative b value, like in this question, it's going to turn into a positive b value. Please pay attention to that. It seems very simple, and you're probably wondering, why is she even pointing that out? It's so obvious. But that is the #1 mistake made on the test. So please do not screw that up. Okay, now we're going to plug in our information. So since I have a -4, it's going to be -4. That's going to change my -4 into a +4. Plus minus. Do I have to calculate the whole discriminant again? No, I already know what b squared minus 4ac is equivalent to. Can someone tell me? What did we calculate? Yep, 40. Good. So underneath the square root sign, I just have to put the number 40. You can't forget the square root sign because now that's part of the quadratic formula. Now I'm going to put that all over 2 times my a value, and my a value is +2. So I have negative times -4 is +4, plus minus the square root of 40 all over 4. Now this plus minus in the quadratic formula is the part that's going to give me 2 different roots. But before I can go on forward from this question, I want to simplify this square root 40, okay? I want to simplify it. So let's simplify it on this side. Square root of 40. That's called an entire radical. It hasn't been broken up yet. I need to break it up into a simplified form. So can someone tell me 2 numbers that multiply to 40? 2 and 20. Good.